Hello and welcome to today's session about no-code data science with Alteryx in the cloud. Today focused on telco customer churn prediction use case. My name is Jan Laznička and I work as a data engineering team lead at Billigence. And who are we? Well, we're a data consultancy founded more than 10 years ago in Sydney, Australia, currently with offices all around the world, including San Diego, Stockholm, Prague, Singapore, and our headquarters in Sydney. Our motto is that we're transforming the way people work with data, and we're doing it through our four main pillars. First of all, cloud analytics and data architecture, which is all about building the right data architecture, normally in the cloud or hybrid, to actually fit our clients' use case and fuel their analytics and their data-driven decision making. Second, data engineering and automation, which is all about taking the data from the source systems and building the right data pipelines so that we get the data in the right shape to the right people. Third pillar, data visualization and advanced analytics, is all about taking this prepared data and presenting it to the right people in a right way so that they can really make data-driven decisions based on the data insights. And our fourth pillar, data governance, management, and strategy, is all about governing this whole pipeline, these previous three pillars, so that we have our data secure, so that we have one source of truth, and so that everybody knows what kind of data to use in order to answer their questions. The use case that we're going to have a look at together today is telco customer churn prediction. In the highly competitive telecommunications industry, it's really important to retain your customers. And it's much more cost effective from some sources, even 6 to 7 times more than effective than acquiring new customers. And even a small reduction in churn rate can significantly impact the company's bottom line. And the customer churn analysis is basically a classification problem, because we're classifying our people on those that are likely to leave us, likely to churn, and those that are likely to stay. And as such, it can be treated as a machine learning problem. Our approach to it is an end-to-end solution with Alteryx Analytics Cloud, which I would like to present to you today. It's great because it's even less technical people can utilize the great no-code features of the Alteryx Analytics Cloud platform to build production-grade data science workflows. And that's what we're going to have a look at today. We're going to see end-to-end no-code data science. We'll use the Alteryx Analytics Cloud modern cloud components to do it. We'll use things like automated feature engineering, automated machine learning, and finally, and most importantly, we'll then design how do we deliver the insights of this machine learning to the business. As I mentioned, Alteryx Analytics Cloud Platform, that's what we're going to use. It contains different applications, and as such, it fuels the work of different personas. IT, data engineers can use it to extract data, perform transformation, blending, enrichment, and prepare the data sets for the analysts. Analysts can do their reporting, further analytics, geospatial analytics, and even the most advanced people, the machine learning crew, can perform data science, AutoML, natural language processing, and then finally we can also present the results through this platform to the business users, which is the key and the most important thing. As I mentioned, it covers the whole pipeline, and that's what we're going to have a look at, from the sources to the results presented to the business. Our use case is telco customer churn prediction. So we have our data sources, in this case in Snowflake. We have the information about our customers, about their services, and about whether they're churned or not. So we have even the customers that actually left us. We're going to use different applications from the Alteryx Analytics Cloud platform to perform different steps of the machine learning pipeline, starting with exploratory analysis and feature engineering in Alteryx Designer Cloud. Once we have that ready, we're going to train the model using Alteryx machine learning application. And once it's trained, we're going to deploy it using Alteryx plans, fuel fresh data into it on regular basis, perform the so-called inference, so scoring of the new data and predicting which customers are at risk and which are likely to leave us. We're going to then take this insight, this information, and present it to the business in the nice and friendly way so that they can take action. So let's have a look at it. So we are in Alteryx Designer Cloud, which is a no-code / low-code drag and drop transformation application that enables us to build data transformation and loading pipelines in the cloud. First of all, on the left-hand side, we have different tools that we can use to transform our data, to connect to our data, and then finally to output the data to the final destination. It's very easy to operate because we just drag the tools from the tool palette and we drop it onto the middle section, which is called a canvas. And then we just connect the different tools with wires in order to perform various transformations, joining, and getting the data into the right shape. If we click on any of the tools in our so-called workflow, we can see a sample of the data as it looks at that exact point in time. So here on the left-hand side, for our customer Telco Churn use case, we are connecting to 3 different tables in our Snowflake Cloud data warehouse. First of all, we have a table about our customers and the services they have with us. Then we have some additional information about the customers themselves in the second table. And then finally, we also have a table with historical information about which customers churned and which customers are still with us. The first thing that we want to do is to combine this data, and it's very simple because we can use the join tool to join all these different data sets together. The configuration always appears on the right-hand side and it's very intuitive. So we just say, well, we're connecting the left input with the right input, and we define what kind of join it should be and what columns we want to keep from both of these different sources. So first we join the service information with the customer, let's say master information, and then we append the information about which customers are still with us and which have already left us. We can click on this output anchor, which is the data set, how it looks outcoming from this join tool, and we can see that now we have our customers with their services, with their additional information about gender, whether they have partners, dependents, etc., and whether they are still with us or not. So now is the time when we actually want to clean the data and prepare it to the right shape so that we can feed it into the machine learning application. Well, first of all, we use the data cleansing tool to actually perform some data cleansing. We are doing different things. For example, deleting unwanted white spaces, tabs, line breaks, duplicate white spaces, and basically getting into the right shape, and also getting rid of nulls and null rows. We just want the information that's unique. Ideally, the information from the warehouse should be already coming in that way, but we just want to make sure that we don't serve duplicates into our training mechanism. So there's a very easy solution here. We just use the unique tool from the preparation tab, and we select which columns do we want to include and make them unique, and we just use the unique output to continue with our flow. We do multiple other things. We can apply filters, either simple filters or advanced filters. Basically, we can input kind of a Excel-like formulas or even SQL-like formulas, depending on what's closer to you. We perform some selection, so not all columns seem to be relevant for our use case. So we might want to get rid of some columns that are not interesting for our use case, and maybe we want to change the data types of some of the columns. Well, the select tool is ideal for that. At this point, we have the data in a nice shape, and the next step that we want to do is we want to bring some more details. We want to bring some more insights because we know that there can be some interactions between different columns. And one thing that we thought of is, why don't we create a new feature called percentage of average monthly payment, which gives us the information about how much a specific person pays for his or her services compared to the average for the same service package, let's say. So first of all, we perform some grouping. For that, we use the formula tool. So again, we can apply different formulas, SQL-like, Excel-like. And then we just aggregate it. So we perform an aggregation here and say we are grouping by these groups, and we want an average of the payments in those groups. We join this information back, and voila, we have our new monthly charges percentage of average feature available for all of our customers. We can see it here as a new column added at the end of our data set. Well, we could perform obviously more of these in one workflow. We could do different branches here, make it really complex. But at this point, it seems that the data are in a good shape, and we want to bring it to our machine learning application. So we should just do a final selection here, and then we can use the output tool, output data tool, from the in and out tab of our tool palette to output the data into the final destination. The final destination can be a database, a data warehouse, so we have many different connectors that Alteryx has, and we can connect to different outputs and different locations, or, and that's what we're going to be doing, we can store the data directly in the Alteryx storage, in the Alteryx Cloud platform. Which is easiest? If we wanted to connect to it from the machine learning application, because that's where the application is, and so the connection is very seamless. So that's what we do. We actually output the data onto the storage, and then we connect to it from the machine learning application as a next step. So now that we have the data in the right shape, as prepared by the Alteryx Designer Cloud application, we can load it into the machine learning and build a model that will ultimately score our customers and tell us which are probably planning to leave us. Let's jump into our customer churn ML project that we have here, and let's have a look at how it's done. First of all, machine learning is an auto ML, which means it's an automated machine learning application that takes us through the process of machine learning and tries to find the best fitting model for our use case. It does so without us needing to code anything in Python or needing to have as much technical knowledge about machine learning. So it's great even for so-called citizen data scientists that actually don't have as much technical knowledge, but still can get production-grade machine learning models. First step, problem setup. So we are connecting to the data that we prepared by Alteryx Designer Cloud. We can clearly see how the data look, what categories they are, so what kind of data types they were classified as. And if we want, we can get more insights by turning on the data profiling to get information about the various different columns, so we can see the distribution of the tenure, so how long normally customers are with us, how many of them have the phone service, it's quite a majority here, then the distribution among different categories, and also the information about the monthly charges, how they are distributed, and we can get the real feel for the data and how they look and how they are distributed. We can also see that we have almost 27% of records where we have customers that have already churned. So we have quite a sample to actually train the model and give it the insights about why it was, what was the case, why these customers left us in the past. We can have a look at even more detail by looking at the data insights. So here we have the correlation matrix where we can see the different features, so-called features, but basically the columns in our data set and how they are correlated together. So there's, for example, a high correlation when people have the service for streaming movies, that they actually have streaming TV and kind of makes sense. But what we can also do here is we can have a look at a correlation matrix between two different columns. So for example, tenure, and if we take monthly charges, see if there's any trend, and we can see that there is actually some trend that the longer the customers are with us, they pay slightly more, and that's maybe because they keep adding more services to their portfolio. So we got the insights about our data. They seem to be in right shape. There are no null values. We took care of that in Alteryx Designer Cloud. Now's the time to define the problem. So first of all, we choose the target column. What do we want to predict? And we want to predict churn. So that's the column that we want to focus on. And now we just pick the right machine learning problem. So is it a regression? Is it a classification? In our case, we are classifying the users into two buckets, those that churn and those that don't, right? So it's a classification problem. We just want to classify them based on their probability to churn. So we select classification, and we can go to the next step, which is the auto model. So here we are, the auto model. Second step of the machine learning process here in Alteryx machine learning application. This is the actual place where the training of the model happens. So Alteryx tries all different variations of possible models and finds the best fitting one according to our selected evaluation metric. I let it run before the session because, of course, this is the most time-consuming phase, and this is where actually the most power is used to try to find the best fit. And currently, we're looking at the leaderboard that ranks the models that Alteryx ML tried. We can see that according to the log loss metric, the random forest classifier is the suggested model. We can try to have a look at different ranking metrics, for example, the classic accuracy, so how accurate it was in predicting the churn variable. And we can see that the random forest classifier ranks highly even in accuracy. So we can go through the different metrics and find the best fitting one that we will actually use for the predictions. For those more advanced, we can actually, before the training, affect what kind of features will be used throughout the training, and if it's going to be just the data set that we brought in, the one that we prepared by Alteryx Designer Cloud, or if we're going to leave Alteryx AutoML to try different variations and derivatives of those columns, and we can influence what kind of derivatives and derived features will be created in the section feature engineering. There are even some advanced model settings that actually affect how the training will be performed, the metric on which it will be ranked and iterated, and stuff like that. In our use case, we found that the random forest classifier performs the best, and that's the model that we want to use. So we're going to pick it here in the model selection drop-down, and we're going to move to the next step, which is the evaluation of our model. Next step, evaluation of the model. We have the model trained. We selected the best fitting model for our use case. Now we want to see how it performs on previously unseen data. Alteryx Machine Learning actually took away 20% of the original dataset and saved it as a test dataset, or here they call it the holdout data. And now it applied the model on this dataset to see how it actually performs and how well it predicts the churn column. So we can see that the holdout score is 0.80, so quite nice. And we can also see the feature importance. So what features were the most important in determining whether the person is planning to leave us or not. We can look at some advanced insights. First of all, we can see the different metrics and how the model performed according to those metrics, but also we can see the confusion matrix, which gives us the information how many of those that actually were planning to leave. So in our holdout data were marked as 1 in the churn column, the model got right. And that's the true positive value here. So it got 237 right, but it also predicted some people that actually stayed as positive, so as 1, which means that this is not a correct prediction, but also it left out some around 136 people that actually left, but the model predicted them to be staying with us. We can look at different metrics here and different performance information. We can also look at the partial dependence, for example, which means we select a feature like tenure, and we can see what was the impact of the feature on the prediction. So we can see that the higher the tenure, so the longer the person is with us, the less probable it is that the person will leave. Another cool thing that we can do in the evaluation are simulations. So we can actually tweak with the data and perform kind of scenario analysis and define here our setup of a person and see if such a customer is actually prone to leaving us or if he's happy to stay. So for example, here I changed the values of contract to month and lowered the tenure to just 1, so a person is just barely starting with us. And we can see that together with the other values of those other features here, the model is saying, no, this person is probably going to stay with us. The prediction value, the percentage is around 70%. So it's quite likely that the person will actually stay with us. So we performed this evaluation. We looked that the model is actually performing well even on the holdout data. And the next step is to take the model to production. So we click next, and now we are in the export in predict window. This actually means that the model is now saved in our Alteryx Cloud platform, and we have the option to actually take it out elsewhere, but we don't necessarily need to do anything here, and we can use it straight away on new data and make predictions. And that's what we're going to do now. We have the model trained. Now we want to use it, and we want to use it regularly. We use Alteryx plans for that. This is an orchestration feature that enables us to run different applications in our Alteryx Cloud platform in a sequence and on a regular basis. I have a plan here for my customer churn. So let's have a look at how it works. It's basically just 2 blocks on this canvas. First of all, I'm bringing a workflow, which is my Alteryx Designer Cloud workflow that takes the data from the original source, prepares it, and gets it in the right shape for the model. Well, and once it's ready, then I'm bringing ML prediction, so machine learning prediction, as a second step. I'm connecting it to the output data of my Designer Cloud workflow, and I'm using this ML prediction to automatically score the incoming data set. I can run this on demand, but I can also schedule it and run it on a regular basis. And that's exactly what we want. We want to create a schedule so that every time at a specific cadence, the workflow, this plan is run, and we get fresh predictions that we then present to the business. Well, and that's the final step. Let's have a look at it. How do we present the results of this to the business? Final step. We want to take the results and present it to the right people so that they can take actions and prevent the people from leaving us. We have multiple options here in Alteryx Cloud Platform, whether it's the reporting application, the Auto Insights application, or even further continuing with the Designer Cloud. But here, Today, we want to build a web application, and for that, we're going to use the app builder. This is how it looks. This is our application behind the hood. So, as you got the feel from Alteryx, we are doing things drag and drop here. And Alteryx App Builder is no exception. So we have all these different options how to actually construct a flow that actually creates the application. So we connect to the results of our prediction. We kind of format it in a way that's useful for our UI. We add some manual inputs for filtering, and then these orange boxes are the actual objects that will be placed on the application. And that happens in the design tab. So here we actually take those different components that we prepared in the previous step, and we put them on a nice UI and nice application. So here we combine those 4 different orange boxes that I showed you, the 4 different orange tools that I showed you just a second ago, and we're putting them here in as charts, but also as a table. We are adding those filters here in the middle, and we are adding some designing features like dividers, banners, logos, and such. Once we're ready, we can actually hit save and then publish the application so that the users only get a link, don't need to know anything about Alteryx, but are able to use the results straight away. And this is how it looks once it's published. We have a website, we have a URL, we send it to our users, and they can actually dynamically use the data from our prediction and find out which people in our customer base are planning to leave us. So we can see it here straight away. It's sorted. So, for example, Ariel Marshall, we definitely should take some steps here to prevent Ariel from leaving us, and also the other people on top of our list. We can also search. So, for example, I know that I have a person called Riley King that I want to have a look at and see if Riley King is planning to leave us or not. So here we have Riley, churn probability only around 9%. So I think we're safe here. No action needed at this point in time. And this is a way how we can easily present regularly updated insights of actually in behind the hood fairly complex machine learning model in a nice way to the business, all within one software as a service platform. Okay, so a final summary. Our no-code telco customer churn prediction use case, where we're trying to detect which customers are planning to leave us, all done within the Alteryx Analytics Cloud platform. First of all, we connected to the data sources, and we used Alteryx Designer Cloud to get the data into the right shape and form. We even performed some initial feature engineering. Then we used the Alteryx machine learning application to train the model and find the best fitting one for our use case so that we can score our customers on a regular basis and see which of those customers are at risk. Once we had that ready, we used the Alteryx plans to deploy this model and regularly run it on freshly incoming data and get the fresh scores of our customers. Well, finally, when we have the scores ready, we want to present them to the right people. And that's what we did using the Alteryx App Builder. We created a web application that we can then expose to the right people so that they can take actions and prevent people from leaving our company. Thank you very much for your time and have a great day.